The first step is we want to graph.
This one is algebra.
Yep. Graph each linear inequality. You are going to want to get it into slope-intercept form, where you can see the slope, you can see the b. We practiced this yesterday. You could also have it in standard form. And when we had it in standard form yesterday, what special points did we find? Yesterday we had a couple in standard form. We found 2 special points. Anyone remember what they're called? Okay, then you're going to shade. How do I know which side to shade if I'm not sure? What should I do? Test the point. The easiest point to test is 0, 0. Could I have used 0, 0 to test on this last problem? If you look back at your graph, could I have used 0, 0? No, because one of your lines went through 0, 0. It was part of your solution. Well, it was part of one of the solution regions. So you cannot use 0, 0 to test everything, only when it's not part of your line. Then you're going to repeat this for all of them. In our case today, in that first example, we had 3 inequalities. In this next example we'll do together, we only have 2. I know we ran out of room a little bit. But when we're talking about the solution, what are we looking for? But how do I tell from a graph of inequalities where the solution is?
The solution region, right?
Right, so how do I tell which one's the solution region?
The ones that are all shaded in.
You're looking for overlapping of the shading. We need to write an inequality for this first piece of information. 6 people in minivans, 4 people in SUVs. So first, I'm just going to let M be the number of minivans, so I'm going to define my variables. I'm going to let S be the number of SUVs. Is that okay? We use C for cupcakes, M for muffins. We have to define our variables, and now we're going to write an inequality, and it's going to be in standard form. Do we know a total? Kind of. We know at most there will be 155 seniors attending. How many people can go on each type of vehicle?
4 and 6.
4 and 6. So I'm going to write 6M plus 4S. That has to be less than or equal to the 155 seniors that could possibly go on the college visit. Are we good with that first inequality? The budget for transportation is $600. The minivans cost $22 each to rent. The SUVs cost $18. Write an inequality for this. Again, do we know the total?
Yeah.
600. I'm going to use M and S again. So I know that it costs $22 for the minivan, $18 for S or SUVs. Can I spend more than $600? No. Could I spend equal $600?
Yeah.
So again, it's going to be a less than or equal to. So the number of minivans and SUVs has to be less than or equal to with those costs. All right, we've got 2 inequalities. So then we're looking for a double shaded region. So right now I want you to try to graph these. Let's graph them. How much does the graph go up by? You can scale it however you'd like. So if they're both in standard form, what special point should we identify that might help us?
Intercepts.
X and Y intercept. So here's what I suggest. Don't start the scale until you know the x and y intercepts. Does that make sense? Because if I know that one intercept's going to be 40 and the other intercept's going to be 20, I want to scale a little differently. So I'm going to have your teams find the x and y intercepts. Ready, set, go.